Hi everyone. Today we are going to understand one of the most fundamental interview problem, that is contents duplicate. The problem is very simple. You are given an array of integers as shown on the screen. If any number appears more than once, we need to return true. If all numbers are unique, then return false. That's it. Simple problem, but extremely important pattern. Now let's understand the question first. Let's take an example array which has element 1, 2, 3, 1. And here if you see number 1 appears twice. So our answer, so we found the duplicate, correct? Our answer is true because found duplicate, correct? Let's take another example, array of 1, 2, 3, 4, correct? If you see in this array we don't have any duplicate elements, all numbers are unique. So if our answer would be false, no duplicates. Here we just need to detect duplicates. That is the solution for this problem. Now second step, that is in the interview we follow as a first instinct in interviews is the brute force approach. Let me write brute force, correct? So in this we'll write the array again 1, 2, 3, 1. This is given problem. In the brute force approach, usually what we do, we take two nested loops, and two nested loop means, for example, I'll take the first element from the ith loop and I will compare with the other three elements 2, 3, 1. Let me write it for you. So first element is 1, compares with the every other element, that is 2, 3 and 1. Next element is 2, compares with 3, 1. Next element is 3, again it compares with 1. This is two nested loops. And what would be the time complexity? As we knew two nested loop is O of n square. This code works perfectly fine, but what if our n increases or number of element goes beyond 1 million, correct? So that time this code execution will be a little slower. In interviews, O of n square is usually not acceptable when O of n is possible. So then we need to reduce the complexity to O of n, or we need to do a better optimized solution. Correct. So let's go to the step 3. We look for optimized solution. Now think carefully. What do we really need? We only need to know. Correct. So we have an array that is 1, 2, 3, 1. Correct. We can ask a question, or a technique we follow in the optimized version is, only thing we need is, have I seen this number before? That's it. So to achieve this, we need a data structure that stores elements and checks existence in a faster way. Or we can ask, what data structure gives one lookup? Correct. And we know that is a hash set. So let me write for you our strategy. Would be, need a data structure that stores elements, checks existence fast. So we can use HashSet, and lookup is O of 1. Correct. Next, let's dry run this step by step so we can easily understand our logic or strategy. Let me write array once again. Array is 1, 2, 3, 1. So what we will do first, we'll initialize empty set. Correct. Next, in this step 1, we'll look for, we start with the first number, that is 1. So step 1, C1. Correct. We taken 1 from the array, and we'll check is 1 in our set or hash set. So no, right? This is the first element, and then add 1 to our set. Now our set will look like set equals to 1, like this. In step 2, as we loop through the next element, we take the second element, that is 2, and next we check is 2 in our set. Again, 2 is not present in our set, so add 2 in the set. So our set will look like 1 comma 2. In the third iteration, we take the third number, that is 3 in our given array. So we take the 3, C3 is 3 in set. Again answer is no. Then we'll add 3 to set. So our set will be updated 1 comma 2 comma 3. Correct. Same step 4, we try to the next element, and next element is 1. Next element we check, C1 is 1 in set. Our answer is yes, because we already have 1 in our set. So what we do, immediately return or exit. Return true, as we found the duplicates, and we stop here. No need to check further. That's efficient thinking. So what would be the time complexity here? So, and space complexity. Time complexity is O of n. We are using only single loop to iterate, and space complexity as well, O of n. Correct. So next we'll write down the code logic for better understanding. So, give me a second, let me clear. Now let's write logic in simple steps. First is create empty HashSet. Next, loop through the array. Next, we check if element exists in set, then return true, otherwise add to set. Finally, if loop finishes and we have all unique elements, then return false. So here notice something important. As soon as we find the duplicate, we exit the code. Correct? That's clean and optimal. So let's write code for you. So I can write it in Python in an optimized way. And if you want, I would use C# also. Python. So we create a function called def contains duplicate, which takes numbers as argument. We will create the empty set here. Now we'll go for single for where number in numbers. Correct. Now we'll check whether number exists in set. If yes, we'll return true, otherwise we'll add to set. If loop completes without any duplicates, then we'll return false. That's what our logic. Now if number in set, if yes, return true, correct, otherwise add to set. If all elements are unique, then return false. So you can see this is the shorter version of code. So our time complexity would be here O of n, and space complexity would be O of n. Next, if anyone wants C# version, then I would try to cover that as well. Here our function will return bool. Function name is contains duplicate and accepts array of numbers as an argument. So initial we'll create a hash set of type integer, and initialize the hash set with given number. So we initialize the hash set here. Now we'll loop through each element in the array. Int num in numbers. Similar approach. If I seen the number, then return true, otherwise add to the hash set. If number is not seen, add to number, add to HashSet. If number is seen, return true. So here our loop completes, and if we found all the unique number, then return false. This is the optimized version of code we can see, and it is very simple. Correct? You can easily refer in your interviews or so. Let's summarize what we learned. So we'll summarize now. So first we started with brute force approach, correct? Where we achieved O of n square as a time complexity. Next we went for HashSet that makes it O of n, and we are checking every element while inserting. Correct. And finally return immediately when duplicate found. So that is the solution for duplicate, to find the duplicate element. Thank you. We'll see you next video.